A car backfires on the street outside your window. Your body jerks, your shoulders tense, your heart slams once against your ribs. Only after all of that happens do you realize, oh, it was just a car backfiring. You didn't choose to flinch. You never had the chance. Something inside you reacted before you did. Something older than you, faster than you, and quietly working beneath your thoughts since the day you were born. But what is it? And why does it still control your reactions thousands of years after the dangers it evolved to protect you from disappeared? Your brain is not a single machine. It is made up of two different systems layered on top of each other. One is newer, the part you think of as you. It plans, reasons, imagines the future, and narrates your inner thoughts. The other is far older. It doesn't speak. It doesn't reason. It simply watches your surroundings and reacts, faster than conscious thought itself. At the center of this ancient system is a small almond-shaped cluster of neurons called the amygdala. Located deep within the temporal lobe on both sides of your brain, its primary job is simple. Decide, in a fraction of a second, whether something in your environment could be a threat to your survival. Here's the fascinating part. The amygdala doesn't wait for permission from your conscious mind. It doesn't ask whether it should react. It simply acts. Neuroscientist Joseph Ledoux spent decades studying how fear travels through the brain. His research revealed that sensory information follows two different pathways at the same time. The first pathway travels to the cortex, the thinking part of the brain, where the information is analyzed, compared with memories, and consciously understood. The second pathway is much shorter and much simpler. Instead of passing through the thinking brain, it travels directly from the thalamus to the amygdala. Ledoux called this pathway the low road. The low road is incredibly fast. The amygdala can detect a possible threat and trigger a full body response in roughly 12 milliseconds. By comparison, your conscious mind takes around 200 milliseconds just to become aware that something has happened. Do you see the gap? Your body already knows. Your conscious mind is still trying to catch up. That's why you flinch the instant you hear a loud noise before realizing what caused it. That's why you pull your hand away from a hot surface before you fully registered the pain. That's why your entire body braces when headlights suddenly veer toward you, long before a single clear thought forms. The amygdala reacts first. The explanation comes later. So why would evolution design the brain this way? Why not wait for careful, accurate analysis before reacting? Because for our ancestors living on the ancient savanna, waiting could mean death. Imagine one of our early human ancestors walking through tall grass. Suddenly, they notice a long, curved shape lying on the ground. What if it's a snake? If they spend 200 milliseconds carefully analyzing the situation, they may already have been bitten. Natural selection rewarded speed, not perfect accuracy, because the cost of being slow was death. That's why the amygdala is biased toward false positives. It would rather make you jump at a curled garden hose 100 times than fail to react to a real snake even once. Psychologist Arne Oman tested this very idea. He showed participants images of snakes, spiders, flowers, and mushrooms. The results were remarkably consistent. People spotted the snakes and spiders much faster than the harmless objects. Even more surprising, some of the images were flashed so briefly that participants couldn't consciously identify what they had seen. Yet their skin conductance, a physiological measure of fear and emotional arousal, increased almost immediately. Their bodies had already reacted. Their conscious minds had no idea why. What does this tell us? It means that hidden inside every one of us is an invisible threat detector that constantly scans every sound, every shadow, and every sudden movement, without ever asking for our permission. It follows an ancient checklist that we've never consciously seen. Snakes, spiders, sudden loud noises, rapid movement, falling. These triggers weren't chosen by you. They were chosen by evolution, through countless generations of ancestors who survived because their brains reacted quickly enough. Later, Physiologist Benjamin Libet conducted another famous series of experiments. His research showed that measurable brain activity preparing for an action begins before people consciously report making the decision to act. Libet wasn't studying fear, but his findings pointed toward the same remarkable conclusion. Consciousness isn't always the driver. Very often, it's simply the passenger. Many decisions have already been made by other parts of your nervous system before your conscious mind becomes aware of them. Once the amygdala is activated, it triggers the release of adrenaline and cortisol. Your pupils widen, blood is redirected toward your muscles, your hearing becomes more focused. All of this happens before your prefrontal cortex, the rational decision-making part of your brain, has fully understood what actually occurred. The part of your brain responsible for reasoning, careful thought, and deliberate decision-making hasn't even finished understanding what actually happened. And once this chemical chain reaction begins, the rational brain struggles to catch up. That's why an ordinary disagreement can escalate into an argument much faster than either person intended. It's why reading a stressful email can leave your hands trembling even an hour later. It's why a sudden jump scare in a movie makes your heart race, even though part of you knew the entire time that you were sitting safely on your couch. That's because your ancient alarm system cannot tell the difference between a lion hiding in the grass and a loud notification on your phone. And that's the twist most people never stop to think about. Your amygdala hasn't updated its threat list in tens of thousands of years. Even today, it reacts to sudden movement, loud sounds, and unexpected changes in exactly the same way it did when those signals usually meant claws, teeth, or a dangerous predator nearby. But today's world is completely different. We live in an environment filled with sudden sounds and constant movement that usually pose no real danger at all. A door slamming shut, a plate falling onto the floor, a car alarm going off 3 streets away. Yet your amygdala treats every one of these events with the same ancient urgency, because it has no way of knowing which threats are real and which are harmless. This is one reason why modern anxiety can feel so exhausting and confusing. The threat detector that evolved to activate only during genuine life or death emergencies now finds itself firing constantly, often dozens of times before you've even finished breakfast. Notifications, traffic, work deadlines, crowded places, all of these continuously trigger the same ancient survival system. And yet, this very system is also the reason you're alive today. It's the reason you're able to hear these words right now. Every one of your direct ancestors, stretching back hundreds of thousands of years, possessed an amygdala that worked exactly as it should. Those whose threat detection was too slow, those who stayed too calm, or those who always paused to think before reacting, never lived long enough to pass on their genes. You are the descendant of an unbroken line of survivors who learned to flinch first and ask questions later. So the next time your body jumps at a sudden sound before your mind has caught up, don't mistake it for a weakness. It's not a flaw. It's not simply anxiety malfunctioning. It's an inheritance. A 12-millisecond gift passed down from every ancestor who survived long enough to give it to you.